Hello, everybody, and welcome to Unified TV. Today, we have an incredible interview with somebody who I've looked up to for a very long time. I think it was 6 years ago, I watched Nassim Haramein's first movie that came to my attention called The Connected Universe, all about his work, and it changed my life. And then I started showing everybody else The Connected Universe, and a lot of people were like, I don't really get it. I'm like, what do you mean you don't get it? This is speaking to the Einstein of our time. So first of all, Nassim, I want to say thank you very much for doing this interview, and thank you for your time. I've admired you for so long. Thank you.
Oh, thank you. It's so good to have your support. And I'm so glad that you were able to extract something from what you heard that like had an impact or some impact on your life and on your understanding of yourself and the universe and everything that exists.
I would use the word activation. It activated me to continue to the next step in my life, which really is the message of everything is connected to everything else. And you prove that with your formulas and you prove that with your work. But because we've
Exactly.
forgotten that, there's war and greed and corruption in the world. And I think through science, you're actually going to be able to dissolve those, dark realities in the world that we live in today.
Well, I think, understanding who we are is like a fundamental question, and understanding what is this world we live in and how it function and the basis of it. And when you get to the basis of it, you find things that are highly nonlinear in terms of like you find things that have to do with infinities and black holes and all kinds of things that is telling you that there is something really incredible going on at certain levels. And at the same time, that tells you there's some kind of like ordering principle,
Yes.
that is order that's emerging from this. And that's a really important part that's often overlooked. And when you look at this order, but as well, like the concept that things, can emerge from very, very small volumes, meaning like even the Big Bang Theory starts with a singularity, a Planck scale object, which is billions of times smaller than an atom, from which the whole universe came out. When you're arriving to conclusions like this, it's like there's non-linearity. There's things that are emerging that are telling you there's something really deep and fundamental about how things are connected. But that can be a philosophy, or it can be a direct consequence of formalism, of equations. And in this case they are, and not in a loose way. It involves the mass of matter, the energy of matter.
So everything that you do is, I'll call you a physicist. You're an expert in physics. You know how all those things work, but you are one of the few that I see bring the spiritual component into your work as well. If there's something bigger here, there's an interconnectivity of everything over here, which is it's a beautiful thing, because when people think scientist or physicist or whatever it is, they're like, oh, no God, no nothing, no order, random. And you bring the exact opposite approach. You're saying, no, there's an order here, and there's a beautiful intelligence here, and call it what you want, but it's there.
Jason, I know exactly what you mean. And I'm looking at it from the other angle, from the other side of the wheel, right? The wheel spinning between you and I. And for you, it's going clockwise. For me, it's going counterclockwise. I'm coming from the other side saying there's actual physical reality that leads to very complex, highly self generated systems that if a society does not understand these fundamental mechanics, it appears as something magical So I want to be clear here. I'm not like saying spiritual doesn't exist. I'm actually saying spiritual is the material world. It's the way things are, right? So it's just spiritual is like without the formalism necessary to actually understand the mechanics of it. And
You're
when you
giving order to the things that we call something we can't understand. You're tapping
exactly.
into the order. Absolutely. Absolutely. It's awesome. It brings me to one main question over here. And I think Albert Einstein tried solving this before he died, that unified equation. Can you speak more about what you call that unification theory?
Unification theory is not what I call it. It's the standard description in physics
Mhm.
is a unification of equations that involves gravity. So relativistic equation, even Newton's equation of mechanics of gravity, and quantum physics, the theory that describes particles and fields at the quantum scale, meaning for atoms and subatomic particles and the stuff that makes up the stuff. And so there's the theory of gravity that deals with the big stuff,
Mhm.
like the way the big stuff moves and how it interacts. And then there's a theory that deals with the small stuff, which is quantum theory, which says something different than the equation that deals with the big stuff. Like the equation for the small stuff says that things are quantized, they're in packets. And the equations for the big stuff says that it's smooth. So gravity is a curvature of space, meaning space curves in the vicinity of mass, right? And it's smooth, right? It's not granular, it's not quantized.
Mhm. Mhm.
And what I've shown is that it is quantized. It's just quantized at a scale that is billions of times smaller than the atom. So it appears smooth from our perspective. And that's how I unify the two, right? So think of water in a bath and think of you're in the bath with your rubber ducky. Do you have a rubber ducky?
Not
If you don't,
anymore.
I'll have to send you one.
I need
Yes.
one. I need you to send me one.
Yes. Okay. I'll definitely send you one. You can do the experiment yourself. And you can, when you pull the plug, your rubber ducky, if it's in the vicinity of the drain, the rubber ducky will start orbiting. And if you were, as if it was attracted, right? And if you were to look at the surface of water, you would see that it's curving towards a drain.
Mhm.
Huh? And the rubber ducky is kind of like appearing to go down the drain because it's curved, which is what Einstein described. He described that gravity is like you put a ball on a rubber sheet and it curves the sheet, so any other ball appears to be attracted like that, right? Well, in the water bath example, the bath example, you can uh, see the surface curving, and that's what Einstein described. But you know that the surface is curving because all the particles of water are spinning in that region that's making the curvature. And so that has not been understood clearly, like formally. That is, the equations of Einstein actually tells you that that's happening because it's actually fluid dynamics equation, but it doesn't tell you what the fluid is made of. Like Einstein didn't say what space time is made of. He just said mathematically it's going to give the right answer for gravity, but it didn't say what is that thing that's curving, like what is that rubber sheet, right? So there's not really a good explanation for gravity, this like in the standard model, like, and most physicists will admit to that. It's not, the source of gravity is not clear because you have to have a mass, and where's mass coming from? Mass is energy, so it's a density of energy that's curving space time. These relationships are not well understood. So I'm trying to give you a short answer, but it's a big
Yeah,
question.
yeah.
And but when you zoom in onto the structure of space-time, just like when you zoom in on the water in your bath, you find that it's made out of particles. It's made out of little protons and electrons that make up the molecular structure of the water. And as they go around together, when they're coherent together, they make an effect, a global effect of them all moving together that gives you a curvature, and that makes the rubber ducky want to orbit towards the drain. And that coherence is because there's a little bit of a gradient in the drain between the water going down and the air coming out. So now you have air coming out. And so that's another flow. So imagine that space-time is a flow of little particles, just like the flow of the particles in your bath make that vortex. If space-time is a flow of particles
Mhm.
that's spinning, then it's going to create coherent vortices that are going to have a certain energy, and they're going to have a certain, force. They're going to produce a certain force and all this. And when you calculate that way, you find the right answers for the mass and the and gravity and charge and all this, like. And so you unify physics because you're using the small stuff to describe the big stuff, the big effect of gravity.
Well, it makes sense. That's your whole, the micros, the macros, above, so below. It's all a reflection of everything else, which I know you've showed many times in nature and in science. It's
Yeah, so that unifies physics.
so what do you do with that knowingness? So now let's say, we figure that out. What's next?
Well, all of a sudden you realize, okay, then there's this flow. If I understand it better, if I try to like describe it, and I look at all the dynamics of that flow, so there's going to be places that are more turbulent, places that are less turbulent. There's going to be places where it's more coherent and places where it's less coherent. And places where it's more coherent, there's going to be more energy, right? And places where it's less coherent, there's going to be less energy because there's more interference waves that are like canceling each other out. And it's like, so you have asymmetry and density change in the system. And so that's continuing to produce flow. And then you realize that flow is not isolated, it's inside flow. And it's inside a bigger flow. And it's inside a bigger flow.
And it keeps
And
going.
it's inside a bigger flow. Yes. And so what appears incoherent to you locally is just because it's the movement of the bigger flow. So because you have your nose in it, you can't see it. If you say, if that's true that you can't see it, you would say, well, then is there a flow I can see? And yes, there is. You call it matter.
Ah, I understand. Okay, so now as we zoom in or zoom out to those infinite bigger or infinitely smaller flows in both directions, the biggest question is, how did all of this start? Was there a starting point?
Well, that's the hard part. When I discovered this, I was isolated for 5 years in a van. I wrote this in the '90s, early '90s, and I reached that same conclusion that there was no possibility. There was an infinite gradient. That is, this infinite density change from infinitely big to infinitely small, so it's non-linear, and this is why we find black holes. This is why I concluded that everything had to be inside black holes, inside black holes, inside black holes. Now we've figured out the universe of black hole is finally, reaching the masses of the physics community as well.
Yeah.
And that, because that's actually, literal. When you do the equations, you find this the the universe is dense enough for its radius to be a black hole. But then you start to realize, okay, well, then this should be a black hole at the center of galaxies, which is the conclusion I did, and all this. But when I got to the point where I was like, okay, then there's no start, there's no end, I had to let go of the concept, you know, because all I could say is that there's cycles, and you see that in nature everywhere. You
Yeah.
see cycles. You see cycles of destruction and cycles of it, of creation, and not in a linear way, meaning like this creation happening at the same time as this destruction happening, at the same time as this construction happening. And that's exactly those equations of flow that I'm writing.
Yeah, it's a concept that's hard to wrap your head around when you can't think in terms of how we've been taught to think of here and there. Because you're saying everywhere all the time.
Exactly. Well, you can write physics, but when you write physics, you're defining the ground state or the bottom scale that you're starting with, and the large scale that you end with, which is the size of the universe. You're in that scale, so that's what you're studying, right? But that doesn't mean it ends there. You know
Yes.
that
Yes.
it doesn't mean it ends there. It just means that that's what your your measurements in your world should give you these boundaries, right? So and if you understand the relationship between the big and the small, now you understand you, since you're in it. You're in the middle.
I
So
understand.
so it has really deep implications.
How is
You're made out of matter.
how has your life changed as you started studying this more? How do you see the world differently? How do you live differently?
Well, it's barely recognizable, yeah, from earlier time. But you can imagine that, well, when you realize every proton has this relationship to the universe, and you're made out of these protons, and you understand. So I just want to say that what I was telling you about a minute ago, about there's some that are like constructive and some that are destructive, and so there's different coherent states.
Okay.
um the flow that is like going out and the flow that's going in are producing forces, right? So I imagine you have a system, like you think of a proton or a universe, and you have a flow of space-time, which is this fluid dynamics of these little oscillators at the quantum scale, like at the really refined scale. Remember, it's the water analogy with the particle that makes up the water.
Yep.
So now I'm talking about the particles that make the flow of those particles. They're producing a pressure that we call forces. And when, they flow, there's a force out and there's a force in, because it's spinning, right? It's a vortex. It's the water going down the drain, right? So there's a flow out, there's a flow in of the particle, and there's decoherency as you go away from the particle. They're not all co-moving anymore. There's like more like random movement. And if you get away from the vortex far enough, there's enough random movement, you can't see the vortex, you don't feel it, right?
Mm.
It's far from you, it's very flat where you are, but if you're close, it's really curved, right? Well, all this, the description, you know gives you a really good sense that, the flow is actually like feedback. So you have, so think of the little particles that makes up the fluid as bits of information. Instead, in physics, they're interchangeable. We have laws of relating,
Yep.
information to energy. So think of the energy of the flow in and the energy of the flow out. Well, when you think of that in terms of, your existence, for instance, you could say, well, my consciousness is actually my capacity to interact in the flow and what I receive from the flow, right? It being aware of self, right? So it's going out and coming back in, right? You're
Mhm.
looking out and you're finding self, right? In like the lake that you're looking down on the mirror, or and it's you, right? You're aware because you have feedback. So you realize that in life you're constantly producing a field, and it's literal, meaning that you're burning energy to make that field.
Mhm.
Okay, like your carnal engine, you're running at like 100 Fahrenheit, like all day, all night. If that stops happening, like you're not, like you decohere, that's when you decohere. That's when there's more interference, destructive interference than constructive ones, so you decohere, right? So the system undergoes entropy, right? So this flow I'm in, of information is actually what I think of as my consciousness. So then I can start to say, oh, okay, I can influence the flow with my consciousness, depending where I put my intention, what I do, how I do. So that's why it becomes really esoteric on one side, but it's actually analytical to a certain extreme, meaning that I can see from the equations that were written where the equation can lead to, like, this deeper understanding of what consciousness is, or how matter organized to eventually make a conscious human being.
So
So that, yeah.
what you're saying is you're taking the data points and the formulas that we do know, and then you're just further connecting them to say, okay, well, we know that 1 + 1 = 2. So 1 + 1 + 1 + 1 must equal 4. And you're taking it further and connecting those dots.
Yeah, so I've written partially some of these equations. I've not finished because I'm still finishing the unifying gravity with quantum physics part. And I have that now, and I know it's correct because it's extremely, extremely precise on all the physics constants, not just one. Like gravity, electromagnetism, the Rydberg constant. I mean, all the constants, and then like the forces and the masses, and from the proton to the universe, right? So, like, from the Planck to the universe. So I've got the scaling law. You can see stars come out, planets, stars, galaxies, clusters, superclusters. So I know, the relationship, and so you were asking, like, why does it have a huge impact on your life? Is because you start to realize you have a relationship to the whole.
Yeah.
And that's hard for people, but when you write the equations, um you find it, meaning like you literally, fundamentally, like, analytically find the mass of the universe, or all the information of the universe, inside one proton. You find it. When you unify the field and you give the source for mass, because we don't know what mass is in standard physics, um, you end up showing that it's the mass of the universe, uh, expressed through the event horizon of a proton. Like, the mass in the universe is protons, and basically you're showing that it's called a holographic mass solution. That's how I called it. I called it that because it's clearly holographic, right? All the information is present in one, um, and um, and you do the ratio. So imagine you have an equation that has the mass of the universe in it. You're attempting to, like, come up with, like, um, a proton, right? But so it's one little thing in the universe, and you might say, well, that's the mass of all the protons put together, right? So you divide by the number of protons, you should get it, but that's not the case, because there's dark matter and dark energy and all this thing, and you can't just do that way. There's measurements that are being made, and so you have the mass of the proton that's very, very small, and you don't know. So without using the number of protons in the universe, you're just saying, okay, how many of these little vacuum, how many of these little oscillation of the particles of space-time, right, of the fluid, are on the surface, and how many are on the inside. So on the inside is the equivalent of all the other protons in the universe, the mass of the universe, right?
How do you, when you say the mass of the universe, if the universe is ever expanding, how do we define a mass? How does that work?
We can see the relationship between galaxies and stars and stuff, and so we have a good approximation of the gravitational force that would be required for the universe to look the way it looks. The problem is that when they solve those equations, okay, they end up with a mass of 4%, meaning they're missing 96% the mass of the universe to look the way it looks. So they add energy in space that they call dark energy, because they don't know what it is,
Okay.
which is what I'm telling you it is. It's the flow of the little Planck's, fluid, but they don't know, right? So they call it dark energy. And then in the galaxies, they're deficient as well of the mass. They're missing 80% of the mass of the galaxies. So they have to add dark matter in the galaxy to make the gravitational fields correct, so that the stars don't fly out of the galaxy. So you see, they're deficient in their equation. They can only predict 4% of the mass of the universe.
They're not accounting for 96%.
Right. They're calling it things that they don't know what they are, and they can't find them, meaning for decades they've been trying to find dark matter particles. They can't find them, you know, and dark energy, they just think of it as exactly that, the vacuum energy, 0 point energy, the quantum vacuum interacting in the universe and actually making it expand, because it's a negative energy. But without getting into much complexity, the when you take the amount of information inside the proton, you get all the mass of the universe, like the matter, it's called baryonic matter, dark matter, and dark energy. Like, all, you get the correct mass for the universe, right? Like, if you take what's inside one proton, and then you count how many of these little oscillations on the surface, like the waves on top of this thing that's spinning, this little ball of spinning fluid of space-time, and you divide that by the amount that's inside. So you imagine the information that's inside is connected through wormholes through all the other points in the universe. Okay, it's like a big network, but it's reduced, it's shielded to you by the surface. Only one bit at a time can come out of the surface, you see? So you only see a very, very small portion of the mass of the object, and you call it mass because it's the energy you see, right? It's the energy you see coming from the system. But you don't know, inside the system, you got a singularity, you got a black hole. So it goes to infinity in there.
You
Right?
mentioned on that note 0 point energy. Can you
Yeah.
explain how that works in relation to, like, what is that? Where does it come from? What, if we can elaborate on that? Because I hear a lot of
That's a
people,
good question.
but
Yeah, that's a really important question, Jason. Because people that know anything about 0 point energy in terms of the public at large,
Mhm.
In general, think that it's a concept of like crazy inventors that, you know, come up with this idea that you can extract energy from space-time, and, you know, like that it's like new age stuff or whatever. I'm actually in the middle of writing a review paper right on this. And you know, zero point energy is actually the base of all quantum physics, and without it, quantum physics fall completely apart. Like you cannot not have it, right? And and it comes from the father of quantum physics, meaning Max Planck had to account for an extra energy at the ground state. So now let me explain what that means.
Mhm.
Max Planck is generally considered the father of quantum mechanics. It came from his exploration of thermodynamics, meaning it was trying to figure out the emission spectrum of a filament, like a filament in a light bulb, if you'd like. And this emission spectrum is called the black body radiation spectrum. And the thought, you know, experiment is that you have an object that is completely black, meaning any photons, you know, going onto it get absorbed, right?
Right.
And it's gonna radiate thermodynamically. It's gonna heat up, right? Because it's absorbing photon like dark jeans, you know, like black absorb and heats up, right? And so it's gonna heat up, and that spectrum was not described appropriately by classical theories at the time, meaning that the theories of the time said that the ultraviolet part of the spectrum should go to infinity. It diverged. And so, and we didn't measure that when we measured the spectrum of objects,
Mhm.
right? So he tried to solve this, and he realized that if he quantized the electromagnetic spectrum, if he quantized, you know, how the energy was coming out, you would get the correct answer. That's called Planck constant. And eventually Einstein realized that that quanta could be described as a photon.
Can we define a photon as like a quantum of light?
Yeah,
Okay.
exactly. A packet of energy. That packet of energy, he figured out it can bounce off electron and produce electricity, an electric effect that, you know, give them the Nobel Prize. He got the Nobel Prize for this, not for relativity. And so, you know, you could say he was as well part of being fathering quantum mechanics, right? And so this whole mathematical chain of event, um, as they dug into it, and Max Planck realized, wait, there's another term. I can't get the ground state. There's another term, meaning that, like, so if I see the photon as like this little packet of energy, that packet is baiting in like a field that's oscillating, you know, with infinite amount of energy. So that term, okay, it means is it was called 0 point energy, because even at 0 Kelvin, where everything should be under thermal dead, right? Like there's no movement, like there's no thermal agitation, there's nothing happening.
Mhm.
There's still at the ground state, there's still these oscillations in the equations that are like insane, like that go to infinity.
I understand. I understand. So even in the things that we see as nothing, dead, whatever it may be, inanimate, there's still this infinite energy within that.
Right. Because if you zoom in, you start to see more and more activity. Like the wavelength gets shorter and shorter, you see more and more activity. It's like if you were looking at the ocean from far, it might look flat, even with 6 foot waves if you're far enough. right? If you're far enough, even like a 20-foot wave might not show up, right? But when you get close, you see, wow, there's a lot of energy. There's a lot of waves.
You're working on this paper specifically on 0 point energy to explain that and tap
I
into it.
was just explaining what 0 point energy is in standard physics, which many physicists don't understand themselves, meaning it's not well understood the history of 0 point energy. They don't understand that actually all the physics that were written after that are written on 0 point energy, meaning like it's the thing, that at the base. And so, you know, the black body radiation, the base of quantum physics is tied to 0 point energy. So that like you can't get rid of it, you can't remove it. And so you have some of the best physicists in the world, throughout the history of physics, making comments like we shouldn't ignore, an infinite amount of energy. I'm happy to ignore an infinitely small quantities. If it's like infinitely small, like, okay, we can ignore it, we just approximate. And like, but you can't approximate an amount of energy and say I'm just going to ignore it. That's where I grabbed it and said, wait a minute, this is the energy of space-time. That's the granular structure of space-time. That's the atoms in the water, right? At their level, they're really energetic. Atoms are really energetic. I just wanted to make that point that people understand. I'm not talking about some esoteric field that's completely outside the mainstream understanding. 0 point energy is critical, and actually the Wikipedia page, I gotta give it to them. They did a pretty good job on 0 point energy. If you read it in the history of describing 0 point energy, so if you go there, you'll see it. What I'm saying is that from there, I realize, okay, well, now you have the source of the energy for the system to produce mass, charge, electromagnetic field, gravitational field, and all this. And so you're in that field, you're swimming in it, you're interacting with it. Your consciousness is actually a function of the flow of that field. And so yeah, the formalism is important, but the implication on your consciousness and on your understanding and what understanding the world and how you interact with it and what you're doing in it and the influence you have on it and all this is critical, because you're made out of trillions and trillions and trillions of these little things that have the energy or the information of the rest of the universe in it. And you're like looking at yourself when you're looking at the universe.
You know, on the 0 point energy topic for just a moment with our technology, how do
Yeah.
you think the world will change as we understand 0 point energy for real? Not what people think it was, but what are the implications of 0 point energy once we truly master it? How will the world change? How will technology evolve, and so on and so forth?
There is approximations that you can give, but because it's an infinite field of energy, the implications have a tendency to go exponential as well. So let me just say that like one of the low grade application would be direct extraction of energy from space-time. So, I that sounds really esoteric, but we're already doing that. Meaning, when we break a nuclei of an atom, we extract energy from it, right? We extract thermodynamic energy, okay, and electromagnetic radiation and so on from it. And what I'm telling you is that the nuclei, the proton that make up the nuclei, are made out of that field. So we're actually extracting energy from it already. You see what I mean?
Yes, yes, I understand.
And there's better grades and lower grades, higher grades and lower grades of extraction, meaning you could think of like the water going down the waterfall and being, producing a gravitational potential from the lake to the turbine, is a transfer of energy or information from, the mass that's falling through. And as I just explained to you, the mass is that flow as well. So basically, you're extracting flow from the flow of water,
I understand.
and you're transferring some of the energy into electrical power that you're using. So even in the case of a mechanical device like a hydroelectric dam, you could see, because it has a nonlinearity too, because you can't just stop at the dam. You got to continue with the water and realize that the water gets, evaporated and put back into your lake for you to extract the energy. Okay, so there's extraction of energy from the vacuum. The next thing you can do, clearly, because remember the water in the tub example, that means you can create gravity. Now you have control over gravity, because you just got to space the fluid of space-time. And so you can figure that out.
So that
Okay, I'm
means
not
that
gonna.
things like anti-gravitic propulsion technologies are going to be possible with that.
Yeah, I don't like the terminology anti-gravitic. It's like saying darkness is anti-light.
Okay.
I like to think of it as like gravity control. You're controlling where you can make a gravitational field. So you can make one over your head, that is stronger than the earth. And next thing you know, you're falling towards it, right?
So who wouldn't want that? Because I know, go back to Einstein, go back to Tesla, go back in history. There's a lot of times where establishments have said, no, we're not going to let that happen, or, censoring or suppressing information. I'll tell you the truth. Ever since I've seen the connected universe, the way that I see you is those people in our time. That's how I've always seen you as an individual with the work that you're doing. So with the suppression of information that's happened in the past with these topics, how are you seeing that in your day-to-day life now? I mean, you're speaking about controlling gravity. That's an incredible thing to be able to do. But I'm sure that there are some people that say, no, we can't let Nassim figure that out. And if he does, we can't let that come out to the public.
Well, the good news is that a lot of things are coming out to the public right now about exactly that. Things that are flying through our airspace that are defying the laws of physics. No, no, no. They're not defying the laws of physics. They're just defying the laws of human physics. They're doing just fine with the laws of physics. You have to have the correct ones to have that kind of, capabilities. But so the laws of physics, so there's a lot of activity, there's a lot of unfolding of what is been happening, and that's really heartwarming for me. I've got a lot of confirmation of my theories being correct, like over hundreds of different points in physics, so observation or experiment that confirm what I've done, including some big ones like the radius of the proton being correct, and eventually, the fact, because all the way through it I've talked about like there must be beings that have succeeded in, controlling gravity before the humans, because the universe is big and there's lots of stars and there's lots of planets as we can see today. um and so there's probably somebody that got there. We've only got like 200 years of modern, physics thinking. So, give it another few and there we are. The whole nature of our modern society is that we control electromagnetic fields, and we made electricity and we made all kinds of devices to transfer information and all this. The next step is to control gravity. It's not that, far off. But in order to do it, you have to understand what gravity is. And, if you if you have a theoretical space-time that doesn't have any physical reality, then you have a problem to create the force, right? And it's funny, Jason, did you follow what just came out in the news last week? This colonel that was very highly ranked in his clearance and had really clear indication that we have a large amount of recovered crafts that are not from human origin. Now it's all over the mainstream media, and it appeared here in France as well, and so on. And so these are, you know, even if you don't believe that, although there's many others that have mentioned this over the years, people that are highly ranked and so on, the fact that at least there's a lot of data showing that there's stuff flying through our airspace that are doing really amazing things, should tell you that there is physics beyond the physics that humans use, in terms of controlling gravity and being able to interact with gravity.
We know that because 100 years ago, what we thought were the laws of physics are different today because our awareness is expanding. Our awareness expands, and therefore, what we're able to do is different. So, I like how you say the law of human physics, right? Because as our awareness expands, the laws of physics are probably infinite in terms of how it works.
I just want to correct you on that, just to be clear. You said 100 years ago. If you had said 200 years ago, I would have said, yeah, they're way different. But 100 years ago is about, relativity, Einstein field equation, beginning of quantum theory. So what I'm saying to you is that actually what I've done is like nothing new. I just put the pieces in different places so that they actually start to make sense, mechanically,
A different
what
combination of what already exists, basically.
existed. Yeah. So we're homing in, like we're getting closer, and as we do, we understand better the forces that are occurring in the universe, including gravity. We understand better what electromagnetism is now than 100 years ago. But we still, actually, even for electromagnetism, we have some big holes in the physics, because we have Maxwell's equations, but Maxwell's equations have some nonlinear functions in it that are not well understood. And one of them is how power is transferred. That's really important for the technology that you develop for, 0 point energy technology, or like, if you have to understand that there's parts of Maxwell's equations that are not. Maxwell, when he wrote his equation, he wrote them in the context of thinking there was an ether, which was a fluid-like thing in the space that was moving, and that's how he got to those equations. And then they removed it, and they replaced it with space-time, because basically Einstein was inspired by Maxwell's equations, but he replaced the ether with space-time, and then years later he tried to reverse that. He tried to put the ether back in, because he said space-time has to have some physical reality to produce the force. It can't just be some conceptual mathematics. At the same time, they were finding the ether. As Einstein made space-time, Planck made 0 point energy, right? And so, but all this was never actually put together, like, oh, 0 point energy is space-time, curving, and like all of a sudden it just didn't make sense, right? So it stayed separate because it was developed at different times, there's different histories and so on, and so it was left separate. And so, yeah, you can go back to an ether if you want, but it's a bad word in physics, because they tell you it's been taken out a long time ago, and it's not there. But they replaced it with space-time at the universal level, and 0 point energy at the Planck level. and they never put the two back together. So that's what I did. So
Interesting.
anyway, when you have that, then
Yeah.
you can control gravity, and when you can control gravity, you can make things that are quite remarkable, like wormholes. Part of this is that you understand entanglement at the quantum level as a classical effect. It's called ER equals EPR. You know, ER is for Einstein, Rosen, that came up with wormholes, and equal means that it's equal to EPR, which is Einstein, Podolsky, and Rosen, which figured out that things can be entangled at the quantum scale, no matter what the distance. Like you can have particles that are connected, even if they're across the universe from each other. And if you modify one, the other one will be modified instantaneously, no matter how far they are apart.
When you say when you say wormhole, are we talking about like we think in the movies? You know, you bend space and time, and you could travel very, very far distances like that.
Yeah, except if you go back to the analogy of the tub,
Okay.
the problem is that they wrote the physics on flat space, so they're thinking of the water going down curving, right? And so they show you a worm or like a sheet of paper that's bent where the distance is much shorter between the 2 points on the piece of paper than if you go along the thing. So it's a good analogy, but it's not necessarily the right visuals. The visuals are more like a vortex going into a hub that is a black hole, right? Like the huge vortex we see on top and on the bottom of black holes in the center of galaxies or in quasars, which are like 1,000 light years. At the speed of light, it would take 1,000 years to get to the end of the vortex, right? Those are like more what you should visualize as wormholes. And when you do ER equal EPR, you're saying that entanglement of two particles being entangled across the universe is because there's a wormhole that connects them.
Oh, wow. That's interesting. Wait, so according to what you're saying with these new breakthroughs, are you saying that it's technically possible to break that speed of light in the flesh, meaning moving through from one point to another, breaking the speed of light completely?
Yes, because I can assure you that if there's ships in the space of planet Earth right now, which all the military seem to confirm, right, that don't come from around here. The closest neighborhood is far, and I guarantee you, they didn't come here at the speed of light, right? It's not like they just like spend thousands of years coming to Earth. While we know from entanglement that there's instantaneous relationship, and I want to say this is not theoretical. That is measured in laboratory and starting to be utilized for communication. Meaning we're starting to be able to entangle photons in a satellite and photons on the surface and transfer the information at the entangled relationship, not linearly from the satellite to the surface, but it leaves the satellite and appears. There's zero delay or near zero. I actually calculated it. It's 10 to minus 23 seconds to go across the universe. So the speed is so high, the bug rate is so high that locally there's no way we would measure anything like that. So for us it's instantaneous.
What do you
Right.
think the timeline is to be able to have technology like that, maybe not commercially, but available to human beings to an extent?
Well, I would say that like if what everything that the military is telling us about is true, then I would say that, let me put it this way, Jason. As soon as we have the gravitational drive, we're probably gonna have encounters because they seem to be in that space quite a lot. And that's probably gonna speed our capacity to figure out how to like use the universal wormhole network.
You're saying
And
with the help of entities that have done it already.
right, I'm sure there was trials and errors that we can avoid, you know. But let's just say that, my first thought would not to try to jump into a wormhole right away. I would I would I would take the time to enjoy, the local solar system. But you can imagine that that's going to make space travel available to everybody.
Right now, with what we're seeing on the news, on the media, and it's really ramping up with extraterrestrial life and what's going on, and we have these crafts and we have this technology. There's other narratives being spun now of perhaps there, and when I say they, I'm speaking about the media, not so much extraterrestrial life, but there's this constant narrative that's pushing us into this perception of to be afraid because there's this national security threat and so on and so forth, even though there was never any form of evidence to bring us to that conclusion. To me, and this is just my logic, and I'd love to hear your thoughts on this as well, any nation or life or entity or being or whatever it may be that is able to reach that level of consciousness and awareness to do things like that must understand the unified theory of all. And to me, if you understand the unified theory of all, making it not a theory but a reality, I think the next step is things like war and corruption and greed and all these things in the world that we see today that come out of this illusion of separation dissolve. So to me, it doesn't make a lot of sense that beings that have that level of awareness would be coming here to do something that's rooted out of a consciousness of separation and war.
Yeah, of course. If you have access to most of the galaxy, let's just say that they cannot go intergalactic just in the galaxy. There's hundreds of billions of stars, so, and as we're finding out, there's most of them have planets. There's planets after planets after planet. And like our little grain of sand, is very, very little. And many, many, many of these planets in the galaxy alone are in the golden Knox zone, which is the zone where they're not too close to their star to burn, not too far, to freeze, just where water would be liquid. And then we're finding all kinds of evidence of amino acid flying everywhere. Anyway, so basically, there's a lot of life out there. So obviously, if you're that advanced, okay, so if you're that advanced, right, you have figured out that um you can get pretty well any goods you want anywhere in the universe, right? Like there's so many planets, there's so many stars you can get, like there's so many meteorite that are like the size of like continent, that have all the minerals you can imagine, that you have gravity control so you can build in space, right? So you can build huge structures, you can build structures the size of planets. You have all the water you can imagine, because everywhere we look in the universe we see water everywhere, spectral lines of water everywhere, like, and there's comets. You can capture comets if you want and like melt it down because you got 0 point energy, and so you can just like make water like there's no tomorrow. And so there's like all sorts of possibility, including the fact that you understood how a proton comes out of that field of energy.
Mhm.
So you can literally produce matter. So you don't even have to like go mining some asteroid or some planet or some, you don't have to take over a planet. You don't have to like, there is no reason for you to like end all of the narratives from the people that had direct experience from the military is that they never saw them do anything, aggressive towards us. And all of the, pilots will tell you that, including the pilots that came forward about a year and a half ago and so on. They mentioned it multiple times. We've never seen them and, you know, parts that they're not telling you is that they've been shot at, these guys, they've been they've been messed with. They've definitely been chased, and they've never, showed any aggressive behavior. So, um, it you know, it's really like there's logical problems with the concept, and there's, and as well, like if they wanted to take over the earth with that level of technology, it would be a done deal,
But
right?
like that, it's not even, yeah, 100%. Do you think that their involvement was a part of anything in our history, like the building of the pyramids, things like that?
Well, there, everybody knows I've done research on that, and there is evidence that's like really, really, really hard to dismiss, with thousands and thousands and thousands of pieces of evidence, like that are everywhere in the world, all around the world, that is described by ancient civilization as well, as people that came from the stars and so on. I mean, like you have narrative, you have evidence when you have a 1,000-ton block that's perfectly carved in like extremely hard granite, if not durite, and the symmetry is as clean as you can get from a computer, literally, and no way by hand with copper tools. And it's a 1,000-ton block that comes from hundreds of miles, and in the middle of the desert or in the middle of the jungle, in South America, or like, and it's like no way we can reproduce that today with our technology. Then you got to start saying, and it's like the precision, it's the weight, it's the effort, like everything, like all the calculations you do on these anomalies are like staggering. You can't just explain it away by 100,000 slave pulling on vine ropes. Like it just doesn't add up. Like it just doesn't add up. The blocks are stacked. They're not just smooth. And then when they're stacked, they're like very, very
Perfect.
precisely stacked. Like very precisely stacked.
It's
So
interesting.
so
It's always interesting to ponder on our history and how that connects to what's going on today, because the implications of what you just said over there with the research you've done with the pyramids is that we've had technology that supersedes the technology that we know of today already thousands of years ago. It
right.
implies, involvement with perhaps other races, other life. And I think now is the time where we're starting to become more and more and more open to that. You say that 10 years ago, they'll put you in a mental hospital, say there's something wrong with you. And people are becoming
Well,
more open
I
to it.
definitely got some heat thrown my way. Yeah.
I can see it in,
So
in the hesitancy of how you choose to share certain things of past traumas.
yes, I am traumatized. I have PTSD on the whole thing, I assure you. It's very hard for me to talk about it because in general people try to use that to discredit the physics, and that's wrong. It's actually just a consequence of the physics, and whichever way you want to see it, like the physics in the theoretical physics, or the physics of a 1,000-ton block that's being moved for like, hundreds of miles and put in the place. And I have much more to say about that, but anyway, I mean, with what's coming out,
Yeah.
what's coming out, let's just say that when this latest whistleblower talked about what they have, let's just say that he didn't just talk about crafts that had crashed, right? And then the reason why they crashed is a whole other story that not going to get into. But the um, the ones that are intact, I would say maybe, just maybe, I'm just going to leave it at that. They're not from our era. They're not from the time, you know, they might have been present for a long time, and were found. It just put it that way. Just as a hypothesis.
We'll leave that for another time. We'll leave that for
Yeah,
another.
yeah. Just
What I
as
do
a
want to ask you, one of my questions that I wanted to ask earlier, when you mentioned the Big Bang. So you're mentioning that there's no beginning, there's no end, and that there's this infinite energy in absolutely everything that you're calling, or it is called, 0 point energy. At the same time, you say that there's order to everything. And anytime I hear a scientist or a physicist, the more, the general consensus is when they speak about the Big Bang, they speak about randomness. There was just this thing that happened, and there was a random explosion that created all of this order.
You see that? Oh, you have a problem. All
Okay.
this randomness that
Doesn't make
created
sense.
order,
Doesn't make
right?
sense, right? So
Yeah.
that's why I'm looking and I'm like, how can somebody say that there's this random thing that happened and order came out of it? Doesn't make sense whatsoever. But I already know your answer on that, because the order came out of order. So whatever happened over there was an order. The question is,
Yeah, disorder came out of order. Yeah,
but
yeah.
where does this Big Bang come from? Right? What's going on there? It's such a tough topic.
Well, let's just start with entropy. It's like entropy is the idea that things go towards disorder, right? And it's really important. In fact, there's new equations that are being written by the top physicists and mathematicians on the planet right now to try to understand the disorder of the universe. And they're finding that what they call complexity, or Solskin calls the second law of complexity, um, uh, that this is like a measure of order.
Mm.
And so what I was saying is that in order for something to go towards disorder, there must be a principle that put the order in the first place. And that's what that feedback thing I was talking to you about. Okay. Like, so just to give a little history of order and disorder, or entropy, it was basically invented early on, when we invented steam engines, to try to figure out how much efficiency from the energy we were burning in the coal we could transfer into steam and into mechanical power to run the train, right? So it's really important to try to figure out, you know, how much of the energy will stay, like, will be able to be cohere or transferred into a piston going up and down, to make the wheel go, right? And that there's disorder. It's getting worse and worse, right? Further you get from the source, which is the coal, right? So it gets worse and worse. Highly ordered here. It's pretty dense, high energy packed in coal. It's been packed by the universe, just to say, right? It's been packed by Earth, through millennia of, you know, um, biochemical transformation. And then all of a sudden we burn it, we transfer the energy that it packed into like steam that like runs a piston and so on. And we lose energy and we lose coherency. But the universe gives you coherency in the first place. And that's the part that's not considered, meaning they do the linear equation in one direction, not the other one,
Mm.
not the water evaporating and coming back in your lake, or not, how did the energy get in the nuclei of the atom so you can split it and get it out, right? Like that part, is not explained. The source of mass, the source of electromagnetic field, like that is not given. So it's missing a really big part, and that part is what creates order, which makes it so that you and I are here talking about it. Because for you to be there and me to be here, like, amazing order had to be made. Like, you're made at 100 trillion cell, or 50 to 100 trillion cell, and each cell is made at 100 trillion atoms, and like they're all cohering and they're all functioning and they're all doing the right thing, and all the biology around you is like completely tuned to perfect, harmony for life to come out. It's called the fine-tuning problem in physics. And any change in the ratios of physics anywhere, like the gravitational field to the electromagnetic field, or any change like on the like 12 number of precision of these things would have made it so we wouldn't be here.
And yet we are.
And yet we are. And so basically, this highly coherent part of the equation is the part that gives you access to that field, meaning you realize that, oh, space-time can be coherent, like a flue of a fluid that's becoming coherent, and where it becomes coherent, we have mass and charge and gravity, and when the field becomes coherent because it's spinning. And so, all of a sudden you realize, oh, coherence is part of the equation. It's not just decoherence. So it decoheres and it recoheres, right? We see that in nature. We see a tree, giving fruits, right? And then the fruits fall, and the seed in it, have enough coherency that it can produce another tree, which makes other apples that fall, and then make other, and then you
They
can
keep
have like
going.
an infinite, right? So there's a generative principle of creation, right? As much as a negative, like a decoherency principle, which is part of the cycle that I was describing earlier. So what the flue of field that's going out is decohering, but the flue of field that's coming back in is cohering. It's the middle of the vortex where the rubber ducky turns super fast.
So really this expansion of creation as we know it, what we can call the Big Bang, was not the beginning of anything. It was part of this continuous generating of creation, which is
It's continuously,
there's no beginning and there's no end. That's where it brings us to.
right. It's continuously cohering and decohering. And so it's doing cycles, and that's all we see. We even see stars going through cycles and so on. That's all we see in nature is cycles. We know that energy cannot be lost or gained, so we know it's just changing states. And so, like, really put simply, it's like a continuous, and it can produce a bang, meaning, like, for instance, a star explodes and sends all its material in its surrounding, and what's left in the middle, what do we see? We see a pulsar, or a black hole. We see a black hole in the middle, and it's not because it made the black hole. The black hole made the star in the first place. They have that reverse. Like our sun is a black hole, so
Right
is our
now,
atom.
right now our sun
Yeah,
is a black hole. So you're
yeah,
saying
right
it's
now.
what created it and what will be left of it once that cycle
It
completes.
goes through the cycle. It's called the carbon cycle, and it makes a shell of carbon, and the pressure builds, and then it blows, and we call that a supernova. And then after the supernova is you know, the dust has settled, we see the black hole, and we see planets to start, you know, this thing starts to, you know, cohere around it because it's still in the vortex that the black hole is making. And so it's making smaller eddies, and we call that planets.
And based on what you're saying, as you get bigger and bigger and bigger, there's another black hole, another black hole, another black hole. So
So it's going through cycles where like that black hole is gonna start accumulating matter again. It's gonna make, you know, it's gonna be really bright because all the matter around it is getting all spun up very fast, and it's making more and more and more, and then it looks like a star, right?
so
There's no
can it be said that as we continue zooming out of that picture that never really ends, can it
you
be
know,
said that our universe as we know it is technically a black hole?
that's right, from the inside. But if you were on the outside and you were extremely large, it would maybe look like a star.
That's crazy. Wow. And what is it when you say a black hole? Can you explain what do I know what it is when I see it on TV and they explain it, but can you explain in layman terms what a black hole is and what its implications are, what its uses could be?
Um, yeah, I mean, the standard model tells you it's a direct consequence of Einstein field equation. So it's a direct consequence of general relativity. And it basically says that you can have a mass. And what I mean by mass there, I mean energy, right?
Okay.
Because it's an important distinction to make because it really is an equation of density of energy. So it's not the weight of the object, it's how the energy is dense in that region of space. Okay. So
Okay.
you can have a density of energy that's high enough that even light cannot escape it. Like the escape velocity of a photon is too small, it would just get sucked back in.
Okay.
Okay. So that defines a radius at which light cannot emerge, and that's called a black hole. Eventually, by Wheeler, Wheeler eventually called it a black hole. When it was found, when Einstein wrote his equation, it was called a singularity, but they ignored it because they said it's not physically possible. So it must be the equation that's doing something weird, but we're going to ignore that part. Um, but then, you know, more and more people said maybe it's a valid part and maybe those things really exist, and then eventually we found them. But when I started to publish in physics and talk in physics conference, the general belief was that black holes didn't exist at all. And for me to tell them that there was black holes in the center of galaxies was like fallacy, you know, and I was laughed at, you know, left and right. And then eventually they found the first black holes they found were in the middle of galaxies, including ours. And you know, and at the time I was telling them we live inside a black hole because if you do the math, it actually works. And but you see the black hole of the universe doesn't look that dense, right? I mean, there's a lot of space in the universe. But that's the thing. Bigger is the black hole, less dense it has to be,
Mm.
right? Because you have more volume. So, you know, you need less stuff in there for it to be still dense, right? So basically, if you took the air, like this will give you an idea. If you take the air in our planet, like the atmosphere of the Earth, okay, it has a certain density, okay? It's pretty low because clearly, you know, I can move around and it's not like water, which is denser, right? That would be harder to move. Well, if I took the air that's around our planet and I made it so that the atmosphere was the whole solar system. So all the radius of the solar system to the Oort cloud, which is like the other edge of the solar system, would be filled with this air. Okay, the system would obey the condition of a black hole.
How come?
The density would be high enough.
Oh, so you're saying because it's so big, again, I understand. The ratio is different based on what it needs to be as it gets
That's
bigger.
right. Exactly.
Hmm.
So the center of galaxies, which are supermassive black holes, have about the density of water.
Oh, wow.
Yeah, which is not that dense,
And how do those
right?
form?
Well, that's a good question. In their model, so at first they denied they were there, so then eventually they found them. And then their model was that the star would collide together and merge and make a black hole because all of a sudden there would be enough energy. But then they found that they were there before the stars were formed. So no go on that one. I told them that was wrong. It's the same thing, not understanding that stars are black holes. They think they have it reversed. The black hole comes first, then the galaxy, right? And so, because the black hole is a flue of the Planck plasma, it's a flue of space-time, it's the vortex of space-time. The galaxy come when the stars get stuck in the vortex, and then you see the galaxy. You see? So it's space-time that's spinning and the stuff is getting caught in it, and then you start to see it, but it's there whether you see it or not, right?
I remember in the connected universe when you were explaining spin, something that I'll never forget is it's almost like when you take your coffee and you spin it, you can't really see the vortex, but the second you pour the milk in, you see it moving because you have something to reference.
That's right. And basically the galaxy is like we calculated the mass of the milk in your coffee, but we forgot to put the milk. We forgot to
That's
put the
such a
coffee.
good way of explain. So that's the 4%, the 96%.
Right. Exactly. You got to put the coffee. You can't just assume that space is empty, that it's nothing, that it's full. It's what Einstein called space-time, and it curves to produce gravity.
That's so fascinating. So let's dive into to sum this up and bring this to a bigger close. You're working on something really big right now. I know you're working on a paper. I don't know how much you could share about it and how much you're willing to share about it, but whatever
I've
you
shared a lot about it in
okay.
this conversation.
Okay, so
Uh,
in January, I know you're putting that whole thing out, correct?
yeah, I'm aiming for that. I've been saying in like 3 years that it's coming. So but this is a pretty hard date. It's gonna be around there. Yeah, yeah.
So
But this is how it goes, especially if you're writing a theory. It's so all encompassing, and the formalism is fairly complex, not because the concepts are complex or that the original, like the the base formalism is complex, just because I have to tie into all the complexity that was built in history so that it's understood, otherwise it's not understood. I found this out with
yes.
all my papers. So, you know, I'm gonna make it understandable. And then it's more complete than what I published before because I found chunks of this along the way. So I published the chunks I could figure out as I was going. But now it's together. And so in the next few weeks, we're gonna put out I mean we, because other physicists that are working on it with me, we're gonna are gonna put out a review paper that actually clarifies everything that I wrote until now.
Where can that be seen? Where can that be found? I told you, and I promise you from the second we spoke, I will do whatever I possibly can to bring more awareness to the work that you're doing. And I want to stick to that because I feel that what you're doing is extremely important. So if you can give us any information on where people can follow that, where they could see it, where they can, see that whole thing unfold leading up to that paper in January, hopefully as well, that would be awesome. So we can really bring more awareness to this work.
Yeah, well, people can follow us on resonantscience.org. At this point, it's really important, and we really need your help. Everybody to help bring the word out, because we need this propagated, as fast as possible. This is the path to our future. This is the path to our future. This is the path forward. There's no other path forward, whether it comes from me or anybody else. There's no other path forward than actually starting to extract energy from the structure of space-time as ultimate source of energy for a society, for a culture, and our capacity to control gravitational field. Because any culture on any planet, anywhere in our known universe, will have this issue at one point, no matter how big their planet is and how much resources they have and all this. They will need to be able to fly, and not with, ancient dinosaur juice burning in a rocket, but actually with the structure of control over the structure of space-time. And that's okay. That's an evolution step. And it comes with our deeper understanding of the fundamental physics of the universe.
One thing I'd really like to say on behalf of what needs to be done right now is awareness, distribution. All of these things are extremely important, but there's one thing that Nassim didn't say that I want to say for him, because it's extremely important that they get certain support here. And it's something that I'm going to be doing moving forward to help this mission. We know all missions have awareness at its core to be successful, but a very, very, very important part of this is funding. Funding is a huge part of moving this thing forward, because these things cost a lot of money to bring to the table. There are teams, there are researchers, there are people dedicating their lives. It's huge. Laboratories, all these things. It's a huge operation to be able to run. I don't know the ins and outs of Nassim's operation. I can tell you just by the little that I've seen, it's just the equipment. It's a huge undertaking to make this happen. And the reason why, Nassim knows this, the second I spoke to him, I said, listen, you don't know how much you mean to me with the work that you're doing, because this man is changing the world. He's truly, truly bringing a revolutionary way of seeing things and facing the uncomfortable truths that, a lot of people don't want to look at because of different agendas and interests at hand. And sometimes it's just, I don't want to say that I've been wrong with everything that I've been studying my whole life. That's why Einstein was resisted for so long, because for 260 something years before him, they thought time is absolute. And he said, well, wait a second, time is relative. Well, why do you think that they resisted him for so long? Because for them to accept what Einstein was saying at the time was not just accepting what he was saying. It was for them to say, for the past 260 something years, everything that we've taught, everything that we've done, every dollar that we spent on education, every hour that we spent reading a textbook was based on something that may not be true. And that's a very, very difficult thing to do. So I commend you, Nassim, for being able to stand up and say, listen, let's look at the truth for what it is, regardless of what my ego wants to attach to. Maybe I'm wrong. Maybe I'm right. It doesn't matter. Let's look at what's in front of us. And that's exactly what you're doing, which is why I admire it. You can hear it in my voice. I'm very, very passionate of your work.
Thank you.
What you're doing to bring
But
to
that. Oh.
I want everybody to look at this.
The good news?
Uh-huh.
The good news is that I'm actually using what they already did. I'm not telling them they were wrong. They just didn't have it in the right order, right?
100%. And it's not as big of a punch in the face as we thought it was. It's just saying recombine and reconnect the dots that you already know.
Right.
That's it.
Exactly. And some of these dots come all the way from ancient civilization. That's,
we got to talk about that another time, because there were a lot of ancient civilizations, extraterrestrial life. That's my bread and butter. I love that stuff.
Right.
I love that stuff. And I think it needs to be, brought up from an intellectual state of, perspective, as opposed to, well, this is what I think because this is what I feel. Well, what do we see? Where does the evidence point? And I think from your background, you can really bring a lot to the table with that one day.
Well, it's not even just ancient civilization in terms of, the anomalies I was talking about earlier, but even in terms of philosophy, meaning like many ancient civilization had in the center of their philosophy that there was a field that was interacting with everything. They called it mana, prana, all kinds of different things, and that this field was the source of everything and all this. And I spent 4 hours with the Dalai Lama talking about those things. It was very much present in their culture and so on. And even they had literally they have literally a space particle in their culture, that they describe in detail in their scroll. And so they had things um about the nature of reality, because think about it, if we're made out of this field and our consciousness emerged from it, then it's somewhere in our consciousness, and we might not have the rigorous, you know um like analytical mathematics to describe it, but we could have intuited it for many, many, many eons before finding the formulation, right?
Yes. Yes. And now you're making that more real, which is what's amazing. It's taking the intuition that's been going on with these civilizations for so long, and then turning it into formula science and things that we can actually follow. Again, taking the spiritual stuff and making it even more real, even more physical, material. You're bridging that gap, because if there's a unified field, we can no longer say physical and spiritual. That's implying two separate things. It's saying, oh,
Right,
there's one field here that everything is
right.
connected to. It's beautiful.
Everything is gone. Yeah, and it's connected not just in like conceptual notion. It's literally
Literally.
mechanically, fundamentally connected, and you're part of that connection. And your existence and your consciousness is actually evidence of it. Like you're literally the evidence of the unified field,
It's,
expressing itself and experiencing itself and interacting.
it's a truly, truly beautiful thing. And Nassim, it's an honor to be able to even speak about these topics with you. I want to remind everybody, and there will be a link in the description below. ResonanceScience.org is where you can learn more. It's also where, and I stress this, where you can make a donation. This is extremely important to fund missions like this, to vote with your dollar and to say, we want to support more of this work, because the more funding that Nassim and his foundation has, the more they'll be able to do down the line, and right now with all the work that's coming out.
And there is opportunity to get involved, like, whatever you can do to get involved. If it is for 2 minutes a day to think about what I just said, then that's great. If it is to become a member of the foundation, that's really helpful. If as well, if you're able, then, and if you're looking for investment, then contact us. We have other opportunities as well, like to help laboratory work. Like people, it's really important, Jason, that people understand, doing physics and doing experiments in physics is very, very expensive. If you can help, there's opportunities that we're preparing for people to get involved directly and be part of this growing community, and be part of the future of humanity in supporting, a way of interacting with the universe, of like transforming our world. Like the information of our world is very, very deep, and has a direct impact on your life today. Clearly, if you all of a sudden didn't need a power source for your house, or for your phone, or for your car, or for anything you use, because it's extracting its power from the environment, from the 0 point field, from space time. And by the way, it's not depleting space-time because it has a lot of energy, but it's actually using the energy and putting it back in, just like the water flow through the turbine. You're just putting a better turbine in the flow of space-time. That's all you're doing. And so the basically, you know, this possibility has to be supported by the world. And so we're going to offer really awesome opportunities to get to be part of it, to be part of the world, you know, space exploration, to be part of the new world, the new physics, the new way of interacting with the universe, the next level of awareness, which is emerging very, very quickly.
I look forward to it. I look forward to being a part of it. I look forward to meeting you in person and doing a formal interview to speak about some awesome stuff as well. And
Yeah, that'll be fun.
Going to be great. And I really do want to say thank you, Nassim. You've been a huge role model for me in the work that you're doing, and you've activated me in many ways. So I want to say thank you, and I look forward to meeting you in person soon.
Thank you, Jason. It's so great to talk with you, and you know, please be good, be safe, and I can't wait to hang out with you in your backyard and talk about the stars.
Let's do it. Thank you.
Subscribe.